From the Khan Accounting video, we learned that 2 pi radians is the same as a full circle, which is the same as 360 degrees. Because they both are divisible by 2, we could also write that pi radians was the same thing as 180 degrees. And since this is an equal, you could also write this as a ratio. And there's 2 different ratios that you could write it as. Remember, ratios are fractions. So this could be the numerator. So I have pi radians being the same as 180 degrees. Or I could have that it was 180 degrees was the same as pi radians. So this is the long English speak of it. You know that we don't really write the word degrees when we're writing it. So the next way to write it, the most simplified way, you know that it's 180 degrees. And if you see a pi, it's assumed that you know it's the units of radians. So these are the 2 ratios that we are going to use when we are converting from degrees to radians and radians to degrees. We're going to use these 2, and I'll show you how. So they want us to convert the degrees to radians or the radians to degrees. It has a little degree symbol, so I have degrees, I want radians. So I have 120 degrees. I need to multiply 120 degrees by a common ratio. If degrees are in the numerator, I need the degrees to be in the denominator so they will cancel each other out, which meant the 180 degrees part of the ratio needs to be in the bottom, which meant the numerator needed the radians. So this is the ratio we're going to use for this problem. Now if you put this over 1, we now have a fraction being multiplied by a fraction. Remember, that means you multiply straight across. So we have 120 degrees pi divided by 180 degrees. Degrees divided by degrees cancel each other out, so our units cancel out, which meant we're just left with radian units. Now you need to simplify 120 over 80. Using your fractions, this gives us 2 pi over 3. And we're not going to write the word radians. It's assumed it's in radians because there's a pi in it. So if you found 120 degrees on the circle, that is the same thing as 2/3 pi. So here is our xy axis. 120 degrees is about-ish here. So 120 degrees is the same exact thing as 2 pi thirds. So we're being asked to convert this radian into degree. So I have the negative pi all over 12 radian. Radian goes up here with the pi. It's assumed. I need to multiply it by the common ratio we talked about at the very beginning of the video. If radian is in the top, that means we need the ratio that had radian in the bottom, which meant the numerator needed to be the 180 degrees. Remember, we multiply fractions straight across. So I have negative pi times 180 degrees all over 12 pi. Pi divided by pi turns to 1. So I need 180 divided by 12. Our units are degrees. So we got to make sure we have that. So I have negative 120 divided by 12 gives me 15. So I have negative 15 degrees. So that meant that if I had my xy axis or my circle, negative 15 degrees would have been about right here. And it's the same thing as negative pi all over 12. They are the same. This is the degree equivalent. This is the radians equivalent for this one location. So we have the degree, 135. They want us to convert it to radians. So I have a 135 degree. I need to multiply it by the ratio at the beginning. Since degree is in the numerator, I need the ratio that had degree in the denominator so that they ended up canceling each other out, which meant my numerator had to be the pi. So we're going to make this a fraction of 1. And we are going to multiply straight across. So I have 135 degrees pi, so 135 degrees pi all over 180 degrees. The units of degrees cancel out with the units of degrees, so I no longer have degrees, I only have units of radians. Now I need to simplify 135 over 80. 135 over 80 simplifies to 3 over 4, so this is 3 pi all over 4. It's assumed it's in radians because pi is in our problem. So if we had our xy axis, 135 degrees was about-ish here. So this distance right here was 135 degrees, which meant that this location is also the same as 3 pi all over 4. This is not only 135, it's also 3 pi over 4, depending on the units you need. So we have negative 40 degrees, and they want us to convert it to radians. So this is what I have, and I need to multiply it by my common ratio to convert it. Since degrees is what I have, degrees needs to be down in the denominator, so we need the common ratio that had degrees in the denominator, which meant our numerator was the pi. Make this a fraction so that we can multiply our fractions just straight across. So I have negative 40 degrees times pi, so negative 40 degrees times pi, all over 180 degrees. Units of degree divided by units of degree cancel each other out, so I just have negative 40 pi all over 180. You need to simplify negative 40 over 180. So I have negative 2 pi all over 9. Because it's a pi, this is assumed that this is the radians measure. So here is my xy axis. Negative 40 degrees was aboutish here. So this is the location to find negative 40 degrees. It's also the same location for negative 2 pi all over 9. So degree and radians location for this particular line. I am given a radian because there's a pi in it, and they said to change the radian into degrees. So I am given 5 pi all over 4. I need to multiply it by the common ratio from the beginning. Since pi is in the numerator, I need the ratio that had pi in the denominator, which meant the 180 degrees is going to be in my numerator. I multiply my fraction straight across. So 5 times 180 degrees, so I've got 900 degrees pi all over 4 pi. Pi divided by pi is 1. So I have 900 degrees divided by 4, which gives me 225 degrees. So that meant that on the xy axis, 225 degrees is aboutish here. That meant that this angle right here is the same as 5 pi over 4 if you needed to talk in radians mode. So same location, depending on the units you need, two different answers.